All right, welcome back. Thanks for joining me for this session. This is a topic near and dear to my heart. We are now in the third uh, section of today's conference. We talked about cyber threat intelligence. We talked about test and evaluation, with including adversary emulation and purple teaming and the use of Caldera. And now we're going to wrap up the conference with a section of talks about defensive measures. So what do you do about it? Now that you understand your threat intelligence and how adversaries behave, you have a sense of where you are defensively relative to those threats and how different tools can help you with that. What can you do about it? What can you put into place to actually make yourself safer? So I'm going to give you the first talk of the day today. And this is a sneak peek of the course that we're going to release after adversary emulation on threat hunting. So I've only got 15 minutes today, and that's not even enough time to really go through the introduction to threat hunting that we're going to give you in the course. There's a lot of material to go over here. So I'm really just going to be giving you a sneak peek, kind of superficial overview of the content, so you get the flavor of the kinds of things we'll be teaching in this course. You might have remembered this from the purple teaming talk that I did with Jamie and Michael earlier today, but the methodology that we advocate is this 7-step V methodology, where you start in the upper left with an understanding of how adversaries behave. And for us, attack is the obvious starting point there, the description of that behavior. And then you develop your hypotheses around how to detect that. Then you decide what kind of data you would need to support those hypotheses. Then you pivot from a sort of theoretical research kind of mode in this characterization downstroke of the V, and you pivot into now implementing this in an actual environment. And so there might be lots of information out there on the internet from those first 3 steps that you can filter down based on what you have in your operational environment, the adversaries you're worried about, the technologies that you're using. And so there's a customization step there as you pivot into figuring out what data you're already collecting, what the gaps are between that and what you need, and how to mitigate those gaps. Then moving into an implementation step where you write actual analytics based on your hypotheses and test them out. And that's where all that purple teaming comes into play that we were talking about earlier. And then you engage in the hunt. And essentially, we've got one module for each of the steps in this process. And so that will be a course on Cybrary with lots of different lessons as videos for each one. And each of those modules will then correspond with a badge that you can earn if you're a subscriber. And if you get all those badges, you'll get the certification in threat hunting. One of the things that we've talked a lot about today, but I just want to reemphasize here, is that when we're talking about threat intelligence, there's a lot of threat intelligence that's sort of in the form of lower level IOCs, indications of compromise, like IP addresses, domain names, and hashes. And those are very valuable, and you should be using those in any good defensive suite. But the focus that we have is on the TTP level of David Bianco's Pyramid of Pain, because that's the level of description of how an adversary looks and behaves that is going to be robust over time and common across different actors. And so you can afford to invest more there and get better payoff for your investment. So in 2013, David Bianco came out with this Pyramid of Pain. I've referenced it before. I'm sure many of you know it. 2013 is also when ATT&CK was first being created. So coincidence? I don't know. I think the community was sort of all thinking along similar lines, maybe. But it basically says that the things down at the bottom of the pyramid are really easier for an adversary to modify and evade defenses that are based on those things than defenses that are based up at the top of the pyramid. And ATT&CK conveniently describes what we know from open source reporting about what adversaries look like at that TTP level. So, it blows that top level out into tactics, techniques, and procedures, the TTPs that David Bianco talked about. And with the more recent versions of ATT&CK, we've also got sub-techniques as a layer in between techniques and procedures. So this is a really useful starting point for us. And if we look into the attack matrix, we see this, a nice layout of all of these different techniques. And you can see that this is a tractable problem. There are only a couple hundred of these things. Now, it's still a lot. There's still a lot of work that you have to do here. But compare this with the millions of lower level IOCs that you're supposed to be tracking and constantly are changing in the world. These have stayed remarkably constant over time. And so that's one of the key values that we get out of this. And not only does ATT&CK list for us these techniques, but it gives us all of this great information about them. Procedurally, how they've been implemented, and they give us detection ideas too, and data sources that we can use to detect these things, as well as mitigations. So once we have this good understanding of the behaviors of adversaries, we want to come up with a hypothesis. And an analogy I like to use is if you were trying to defend a neighborhood instead of a network, you don't start with the fact that you have a traffic camera at the intersection between the neighborhood and the highway and hope that you can find something there. Maybe you scan the license plate numbers, looking for license plates that have been used in previous burglaries. That would not be a very effective approach. What we really do is we think through, how do real burglars behave? What are their TTPs? Well, a tactic might be that they have to enter your home. And one of the techniques that they might use is to kick open a locked door. And so using that understanding of their TTPs, we can come up with a hypothesis. And a bad one that we might start with would be, if the door opens, then a burglar is breaking in. And so we want to monitor for when that happens. But there are going to be way too many false positives, right? Every time anyone comes in the door, that will trigger. So we can refine that and say, well, what if it opens while the door is still locked? Okay, now that's more likely to be a malicious activity. And so we're still in the English phase. We haven't tried to write this in a Splunk query. And that gives us the freedom to kind of explore the logic of what we're trying to accomplish here, without getting bogged down in making sure that the syntax of this is correct. And so we advocate that you continue to refine this hypothesis for a bit before you dive into specific data sources or specific query syntax. And we'll talk about how to do that for real attack techniques. For example, with the scheduled task technique. So this is a technique that can be used to establish persistence. And we're going to walk you through how you can investigate that technique and develop a robust analytic around it. One of the first things that we advocate for is that you research the technique with the goal of finding what we call behavioral invariants. So these are the behaviors that occur independently of which tool the adversary is using, what their C2 infrastructure looks like, the particular procedural implementation that they use. You might not always find a behavioral invariant. Not all techniques have behavioral invariants, but we encourage you to try to think about that and see if you can research these techniques to the point where you get as close as you can to understanding those things. Because if those are common across all of the implementations and you can detect those things, you're going to have a much more resilient defense than if you're dependent on something more brittle about a procedural implementation. So we're going to walk you through a process by which you can find behavioral invariants or get close to them and identify ways that you can distinguish benign implementations of these techniques from malicious implementations. We'll walk you through an example of using the attack page as a starting point of how you can understand the technique and using their detection ideas and data sources to guide your research, how you can use a tool like Procmon to see at the lower level what the operating system is doing when these techniques are implemented, to find those behavioral invariants, or what SpectropOps calls choke points in their capability abstraction approach, and identify some things that you can hook into. So, with scheduling a task, there are lots of different ways to schedule a task, but in the end, you have to have a job file written and 2 registry keys set. If those 3 things occur, then the task scheduler will pick up your task and you've accomplished your goal. And if you haven't done those 3 things, the task scheduler won't pick up the task and you haven't really accomplished that technique. And so those are the 3 things that, if we can focus our defenses on those, will be robust about all of the different procedural implementations of this technique. We're going to walk you through how you can take that deep understanding of how these techniques work and map them onto data collection requirements. This is step 3 of the process. And we'll walk you through some common examples of like Windows event logs and Sysmon and the event codes that are associated with these underlying activities. And in this example, we can see that since registry modification and job file creation are really important, that those event codes 4657, 12, 11, these are going to be useful event codes for us. And conveniently, the Windows event log 4698 is specifically triggered whenever a task is scheduled. So it gives us a really good handle onto this activity. So we're going to walk you through that whole process of doing this research and determining what you need. And then the last 3 steps of the process, we're going to walk you through how to take these requirements and bounce them up against what you actually have in your production environment. You might find that a lot of this information is already being collected, maybe for some other purpose. Maybe it's just for IT purposes of making sure that things are up and running. But you might find some gaps. And so we'll give you some options about what you can do about those gaps. You might be able to easily reconfigure a sensor and for no real additional cost, get some additional insight. You might need to buy some new sensors or get some free sensors to augment what you already have. You might want to roll back to like a plan B. Maybe there's a backup data source that isn't quite as good, but you can't get the one that you really want. And so you've got this backup plan. And that might require moving to a backup plan for your analytics as well. And then finally, you might end up with some gaps that you can't fill. But when you follow this process, now you will be able to explain to the network owner what those gaps are, and not just at the data collection level, but how those map back to techniques that you are now going to be blinded to and won't be able to detect. And so that'll help you make the case for improved data collection, but it will also set you up for a much more concrete report out when you do your hunt. So you can fully understand the kinds of techniques that you're capable of seeing and the techniques that will be invisible to you because of these data collection gaps. Then we're going to show you how to map your hypotheses onto concrete analytics using specific syntax and event codes, and walk through a process, an iterative recurring process by which you optimize those analytics for performance and recall and precision, so your false positives aren't too high. And this is where we're going to employ purple teaming. And then finally, you're going to operationalize those, and we'll talk about how you can fuse these atomic analytics that you've developed into a comprehensive view, and then investigate detections when they occur, and explain what you're finding in terms of attack. And so we come full circle back to the CTI part of the triangle. So that's the methodology that we're going to be teaching in that course. Didn't have time to do everything, teach you the whole course today, but I just wanted to give you a flavor for what that will look like in the future. Our next talk is we're bringing back Frank and Jamie, and they're going to tell you about how to effectively communicate the results of adversary emulation assessments for maximum impact. In their talk, Sharing is Caring. So I'm looking forward to that. I will see you there.